You are asked to find the mass, capital M, of a piece of a rock of irregular shape having a mass of the order of 60 grams. While performing the experiment which used the principle of moments, you are provided with only the following items to carry out the experiment. A weight of mass, simple M, it is given as 50 grams. A meter ruler, a knife edge, and a suitable wooden block, pieces of thread. Part A, as the first step of the experiment, you are asked to balance the meter ruler on knife edge. What is the purpose of this step? We can balance the knife edge, balance the meter ruler in knife edge like this before starting the practical. Then we can find the center of gravity of the meter ruler. We are using principle of moment around this point for this practical. When getting this pivot point as the center of gravity of the meter ruler, we can do the practical without using calculations related to weight of meter ruler. Then we can get answer for part A to avoid the weight of the meter ruler. For the calculation, then part B, draw the diagram of arranged experimental setup on the table shown below. For the balance situation, just before you take a reading, mark the balance length L1 and L2 correctly. Take the larger balance length as L1 measured from the balance point in diagram. Label the items. We have to draw wooden block, knife edge, meter ruler, and we have to hang masses. This is the given 50 gram weight, simple M mass, and this is the given rock, capital M mass. They have given mass of simple M is 50 grams, mass of rock approximately 60 grams. It means mass of rock is greater than the simple M mass. When mass increases, balance length decreases. Therefore, this balance length should be the small balance length. We have to mark it as L2. This one is the larger balance length. It is the L1. We have to mark balance length corresponding to the larger value as L1. Then part C, write down an expression for L2 in terms of simple M, capital M, L1 when the system is balanced. We can write the equation by getting torque around this point. I will consider it as point O. Then we can write counterclockwise torque around point O should be equal to the clockwise torque around point O. we can write counterclockwise torque, capital Mg into L2 should be equal to clockwise torque Mg into L1. We can cancel out G and G. We have to give the expression for L2. Then we have to subject L2. Simple M over capital M into L1. Then part D. You are supposed to draw a graph in this experiment. What position of the meter ruler would you place on the knife edge every time when you take a different set of readings L2 and L1? We have to place the meter ruler such that the center of gravity of the meter ruler is placed on the knife edge. Then we have to write on the center of gravity. In part E, suppose you have plotted the graph as follow as shown in the figure 1 to find the mass capital M. Part 1, in this experiment, you have been asked not to take readings for small values L1 and L2. What is the reason for this? We know that when the reading is a small value, percentage error or fractional error is a larger value. Therefore, we have to get large readings to decrease the percentage error. Then we can write to reduce the percentage error. In part 2, by selecting two most suitable points on the graph, calculate the gradient of the graph given in figure 1. The 2 points selected should be clearly marked on the graph using arrows. There are some conditions we have to get when calculating gradients by using a given graph. 2 points we have selected should be between this minimum and maximum point. It is the first one. Second one, the considered 2 points should have a maximum gap. Third one, we have to consider 2 points. We can clearly identify x and y values. Fourth one, we can't get these marked points. According to that 4 conditions, we can get 2 points like this. I will write coordinates. You can check this graph. When getting a suitable value from the maximum side, this side, from this point we can check a point. We can identify x and y values clearly. X value 39, y value 31. Then we can observe from this side. We can get a suitable point. X value 16, y value 13. Now we have to calculate gradient. Gradient is difference of y divided by difference of x. Difference of y means 31 minus 13. Difference of x 39 minus 16. Minus 3, 8. 2 minus 1, 1. 18 divided by 9 minus 6, 3. 3 minus 1, 2. 18 divided by 23. Approximately 0.78 is the gradient. Now I have not considered units because of y-axis is given in centimeters. It means value multiplied by 10 to the power minus 2. X-axis also in centimeters. Difference of y divided by difference of x is centimeters divided by centimeters. Unit is cancelling. Therefore, there is no unit for the gradient. Then part 3, calculate the mass of capital M of piece of rock in kilograms. We can consider the equation obtained in this part. Then considering equation, gradient equals to this value, simple M divided by capital M. Gradient is 0.78. This one is part 2, now part 3. Simple M mass is mass of the given constant weight, 50 grams. We have to convert it to kilograms, 10 to the power minus 3. We have to give the answer in kilograms. Then we can simplify it. 50 divided by 0.78 into 10 to the power minus 3. This is approximately 6.41 into 10 to the power minus 2 kilograms. Then part F, you are asked to find the mass of L0 of the meter ruler using only the items provided above. Expect the piece of rock. Draw suitable diagrams for an experimental setup that could be used for this situation. In the space given below, the center of gravity of the meter ruler should be clearly labeled as G. When finding center of gravity of the meter ruler, when finding mass of meter ruler, we can balance meter ruler with a point like this. It is not the center of gravity. Now center of gravity is in this side. Now we have to balance meter ruler by using the given simple M mass. Then we can measure this length from pivot point to this weight, and we can calculate distance to the center of gravity by using it. Now they have not asked to calculate the center of gravity, the mass of the meter ruler. Therefore, we can draw only the diagram.